Hi and welcome. This tutorial is about the pin description and RAM and ROM memory organization of 8051. So let's start with the pin description of the microcontroller. I have this diagram which is a 40 pin diagram of 8051. Here we have 32 pins arranged in 4 ports, 2 supply pins for VCC and ground, 2 crystal pins to connect an external crystal device, 1 controller reset pin and 3 other control pins. In 8051, pins 39 to 32 are reserved for port 0. This port is bit and byte addressable and bidirectional. The address and data bus is multiplexed with this port, and if we want to use the port for general purpose input output, then we have to use external pull-ups on this port. This port is also useful when we are dealing with the external memories. In that case, we do not need to connect any external pull-up to this port. The pin number 1 to pin number 8 are reserved for port 1, which is also a bit and byte addressable port with bidirectional capabilities. There is no need to connect any external pull-up. Pin numbers from 21 to 28 are reserved for port 2, which is a bit and byte addressable port and mostly used for general purpose bidirectional input or output functions. This port is also not required pull-up resistors externally. If we want to use the external memory for 8051, then the port 2 can be used to extend the address bus, and port 0 and port 2 will form a 16-bit address bar. So this port 2 is multiplexed with higher order address bus from A8 to A15. Pins number from 10 to 17 are reserved for port 3, and this entire port is multiplexed with different functions of the 8051. This port is also bit and byte addressable, bidirectional in nature, and used for general purpose input outputs or for special functions which are multiplexed with this port. The port pin 3.0 can be used for serial reception. P3.1 can be used for serial transmission. P3.2 and 3.3, these are external hardware interrupt pins. P3.4 and 3.5 are external timer control pins, and pin 3.6 and 3.7 are for external memory write and read operations. Next, I will consider the supply pins of the microcontroller. The pin number 40 is VCC, where we can provide 4.5 to 5 volt DC supply positive, and pin number 20 is ground or 0 volt. Pin number 18 and 19 are reserved for external crystal, where we can connect a suitable frequency crystal to clock our microcontroller. The very common crystal frequency is 11.0592 MHz. Pin number 9 is a reset pin, and which is normally used to reset the microcontroller, and there is no other function of this pin. One push button and resistor capacitor arrangement is required at this pin to reset the microcontroller properly. There are 3 other control pins which are labeled as PSEN bar, ALE and EA bar. These pins are pin number 29, 30 and 31. PSEN means program store enable. So this is an active low control signal, and it is used to fetch the external code memory if we are fetching the program from the external code memory, and it is not widely used because it was only used in 8031 microcontroller. ALE is address latch enable pin, which is mostly used to demultiplex the address and data bus during the external memory access. Again, this pin is only useful when we are dealing with the external memory. EA is external access pin, and this is an active low pin. We normally keep this pin tied to high or VCC, because if this pin becomes low, then the microcontroller will try to access the code from external memory. And for most of the 8051 circuits, we will not connect this pin to ground. So this pin will be connected to VCC. The function of each pin of the microcontroller will be more clear when we will deal with the ports and how to configure them in the next few tutorials. Now let's move to the memory organization of 8051. If I consider the on-chip ROM or flash memory, then for standard 8051 it is only 4 kilobytes of ROM. The program counter of the 8051 is 16-bit wide. So directly it can access 64 kilobytes of on-chip ROM, but the manufacturers of controller are not providing this much of on-chip ROM in the controller. On the other hand, if I consider the external memory access, then we have 16 address lines, and 2 raised to power 16 is approximately 64 kilobytes of program memory, which we can access externally. The on-chip RAM is 128 bytes and it is divided into different sections. First of all, we have 4 register banks starting from 00H to 1F. In each register bank, we have 8 registers starting from R0 and ending at R7. The register bank 0 will be selected by default after the power up of 8051, and if we want to select any other register bank, then we have to use the program status word register. We have a bit addressable RAM area starting from address 20H and ending at address 2FH. These 16 bytes can be accessed in bitwise mode, so we have total 128 bits in this area which we can set and clear. The last section of 8051 RAM is also known as scratchpad or the general purpose RAM area. This area is mostly used to store the operands during the operation. So this is just a brief introduction to the pin description and the memory organization of 8051. Thanks for watching and subscribe the channel.